you can build a sci-fi inspired rocket lamp with electronics from Adafruit and CircuitPython. This features NeoPixel LEDs and a speaker to create a rocket-themed white noise generator. At the base, it's got an LED toggle switch for powering on the device. A Stemma QT rotary encoder features 2 modes for adjusting the brightness of the LEDs and the volume of the sound effects. We think it's a great project for young makers to inspire them while they're awake and help soothe them to sleep. It features a mini fan, speaker, NeoPixels, LED toggle switch, and a Stemma QT rotary encoder. This USB cable features magnetic tips and provides the lamp with 5 volts of USB power. Powered by the Adafruit Feather RP2040 and the PropMaker FeatherWing, these 2 dev boards are the perfect match for making advanced props with LEDs and sound effects. The code is written in Adafruit CircuitPython and uses the MP3 library to play back audio files. The Stemma QT rotary encoder features a button and NeoPixel LED to switch between modes for controlling the brightness and volume. Be sure to check out the guide on the Adafruit Learning System for a step-by-step tutorial. With CircuitPython, your dev board shows up as a USB flash drive, allowing you to simply drag and drop files for easy file swapping. You can go to circuitpython.org and search to find out if your dev board is supported. Once you've found your dev board, click the download button to get the most recent version. We think CircuitPython makes developing hardware projects fun and easy for both beginners and experienced engineers. Get the parts to build your own rocket lamp by checking out the links in the description. Download the free CAD files and 3D print the parts in your favorite filaments. We'll start by soldering the various cables and components to the PropMaker FeatherWing. A 3D printed bracket snap fits over the speaker and gets secured to the PropMaker FeatherWing. The mini fan gets sandwiched in between 2 brackets with mounting tabs for securing the feather. Socket headers allow the 2 boards to press fit together to create a layered stack of components. 2 NeoPixel rings are wired together and press fit into a circular bracket. The component stack is then secured to the NeoPixel mount with machine screws to create the core of the rocket. The body of the rocket is then fitted over the core and secured to the outer tabs. All of the cables are routed through an exit hole on the side of the rocket. A DIY ribbon cable allows the dev board's USB port to be accessible in the control box. The cables are press fitted into a wiring channel built into the rocket's umbilical that gets secured to the side of the rocket. To hide the wires, a separate cover is press fitted over the umbilical stand. Cables can then be routed through the top of the control box with the umbilical stand secured with machine screws. The rotary encoder is soldered to the Stemma QT breakout board and gets panel mounted to the top of the control box. A JST cable is wired up to a pair of quick connects that are clipped onto the toggle switch's terminals. The LED toggle switch can then be panel mounted and plugs into the corresponding JST cable. The USB ribbon cable press fits into the notch near the bottom of the control box. Optionally, a beefy LiPo battery fits inside the enclosure to make this project portable. The bottom cover snap fits under the control box to keep everything intact. Colored tissue paper can be used to create a flame by layering together cutout shapes to form the rocket's exhaust. The paper flames are attached near the blades of the mini fan with double-sided sticky tape. Lastly, the top of the rocket snap fits over the booster. We hope this inspires you to use CircuitPython and parts from Adafruit to create your own props with lights and sounds.